Okay, hi. Okay, guys. Um, so we will talk about agentic AI system architecture. Okay, so basically we will talk about Langchain and Langraph. Okay, and as this is a workflow. Okay, and basically we will understand this paragraph, this graph, and this and this. Okay, so basically. Hmm. Okay. So here we are learning an agentic AI system, okay? And based on the diagrams, if you are seeing that, the first one is here user input, okay? Correct. So it's mean the user will put an input and then it will comes to the Langgraph. What is Langgraph? Okay, so Landgraph and Langchain. Basically, LangChain is used for chaining all the details, all the info, and it will send to LLM. Okay, it's sent to the cloud LLM. So what contains the LangChain? LangChain contains the user prompts, LangChain contains the question query, LangChain contains the semantic search. Okay, so these are the things the LangChain contain. Okay. Okay. And what's Langraph? So Langraph basically provide a human in loop, and it will provide a graph structure. Okay, graph structure means the conditions apply on a Langraph. Okay, so based on the conditions, based on the conditions, it will run. Okay, so it will run like what? Suppose there are conditions. Okay, if the condition is true, then it's going to see if the conditions are wrong, then it's going to be okay. And if anyone fails, then it will start the retry. Okay, so this is the Lang graph. So Landgraph basically it starts with the state, okay, human content, like message input. So here is the message and the input is type human content. What are these solar panels? Okay, it comes to the agent. There's a node, okay. So node will be agent, interacts with customer, obtain monthly energy cost, okay. And then it will start flowing the state, okay. Where to go, okay, and what's the edge, all these things. So this will who will decide? This will decide by the Langgraph, okay. So here it will comes to the tool, okay, like energy cost estimate, pi, and all things, and this will start to the agent, okay, and until it satisfies its answer, okay, and then it will go to the end, okay. So basically it's the line graph. What is agent? An agent can do multiple things, okay. Human in loop, decompose, plan, execute, observe, final answer. If final answer not found, then it will again recompose, plan, okay. Now here if you see the agent have LLM, memory, tools, objectives, it all things an agent can have, okay. And based on this it will decide what to do, okay. It will decide what to do, okay. So here a line graph basically decide what to do after the user input provided, okay. Maybe it will go to the research agent, maybe it will go to the generate startup pitch, okay, all these things. And if it goes to a research agent after the data, the response, it will comes to the LLM chain, okay. After LLM chain startup pitch, it will generate an answer, okay. It will generate a response, and based on the response, okay, retrieve similar startup ideas, all these things, and then it will return the answers, okay. Correct. So basically this is the line graph, okay. So Langchain is input, chain, output. Langraph is input, chain A, chain B, chain C, output. Okay. So the chain A will decide where to go. Correct. Langchain and Langraph are the tools to help build AI workflows. Langchain works in a step by step, while Langraph allows more flexible path. Both makes it easier to connect AI models with data and tools to create a smarter application. Okay. So here, which frameworks to use for LM applications? LangChain, ideal for applications with a clear sequence of steps and model design. Suppose if we are designing and RAG, okay, then the LangChain will work. LangGraph, best for complex adaptive systems, require context awareness and flexibility. If we are avoiding the MCP tools, there are multiple tools we have to choose. Okay, so then the LangGraph will come. Okay, correct. Here's the LangChain. Okay. So LangChain is a workflow designed to connect large language models in a structured workflow, enabling multi-step reasoning and automations. Okay. Purpose, it simplifies building AI applications that require chaining multiple steps together, such as processing user input, retrieving information, and generating responses. Okay. So this is the purpose. Structure use chains, as we see already. Okay. Input and chain and the output. Okay. So now, if you see the diagrams, the PDF will be chunks of context, and this is the embeddings. Okay. So here are their question. What is neural networks? Okay. So it goes the question and converted to question embedding, semantic search, vector store. It will search by this. Okay. The semantic search, and it will retrieve the similar data, okay, and then it will rank which one is correct, okay, and then the chunks and our questions will goes to the LLM, and final response the LLM will notify as an answer. Okay, so this is the chain. Langgraph. It helps build AI applications where tasks can branch, loop, or run in parallel, allowing more complex logic than sequential chain. Okay. So if you're not running anything sequential, then you have to use the Langgraph. That's simple. Okay. Now here, start an assistance. Okay, assistant tools will add here. Okay, and you ask a question, write a sequence. After writing the sequence, it will comes to the tools. Okay, so basically when the tools will run, then it will leave the sequence and it will go to the end. Simple. Here is the Langchain with Langraph. Goal: connect steps in order for structured, okay, multi-step reasoning. Build flexible workflows using Langraph style task flow. Okay, okay, that's great. Flow type works in a straight step-by-step manner. Support parallel, condition, and adaptive path. Okay, limited flexibility with fixed order of steps. Very adaptive with loop, branch, and complex logics. Ease of implementation. Simple to use for straightforward tasks, more advanced setups needed for complex workflows. Best used for chatbots, document analysis, and summarizations, multi-agent systems, dynamic AI pipelines, and adaptive planning. Okay, it's great. It's great. It's great. I have worked on that. Okay, but model that's NLP. That was crazy. But bidirectional encoder representation from transformers is a machine learning model designed for natural language processing tasks, focusing on understanding the context of text. Okay, so input, the input part, and it classifies yes or no on the output. Okay, uses an encoder only architecture from the transformer models, process text by considering both left and right context simultaneously. But within board fine-tuning, board architecture, so application of boards, text classification, question answering, named entity recognition, NER. Okay. So here's the organization and coding the board. There are some codes and okay. So today that's all. Okay. Bye bye. We will see that later. Thank you. I had to fix my posture. This is my normal posture, but yeah, I had to fix.